All right, so for this part, we're going to reuse some of the code we just did here and control the program via a loop, which means as long as we don't pick 3 to exit, we will remain in the program. Now, the most important part about this program, or the learning objective out of this, is to really understand how to use a function that returns a value. So that's the main objective. Secondary objective, or a bonus, if you want to say, is we want to make sure that the actual program is a little more practical. So in our case, we want this menu to run within a loop. And as long as we don't pick 3, we remain in the program, or the program remains running. Okay. So from the previous video, we've learned that if you have a return statement within a function, then make sure that you understand the data type of the value or the variable you're returning, which means it has to match what you declared in the function definition ahead of it. And then when you call it, make sure you have an actual variable waiting for the display menu or the function you're calling. When it returns with an appropriate value with a matching data type as we've seen here. Okay, so now let's go ahead and let me just recopy all of this, because our next code is really an enhancement of this. So let me just copy it here. Let's create a new file. And I'm just going to paste this and make some changes. And call this one 38, and add to our learning objectives. Okay, secondary learning objective, review of loops. Okay, all right, so we're going to keep that function display menu. What we're going to do is we're going to do something totally different in main right here. So let me just kill this up right here. We'll start main from scratch. So if I save this file as example 38 and compile it, at this stage I haven't called display menu, so I'll simply get the system pause output, which is press any key to continue. So let me just copy the name of the file here, save it, and let's compile and run. Okay, like I said before, just press any key to continue. Let me just make the fonts a little bigger. Let's go for 36, good. Right there, okay? Why? Because in main, we're not doing anything in terms of calling display menu. However, this time, I would like to call this display menu within some sort of a loop, and as long as we don't have 3, we stay. So how can we do this? Well, you could do a do while loop, do, and then while, and it's going to be based on option not equal to 3 semicolon. So this is a do while loop. Do not forget to put a semicolon. Now let's get into the body or the loop, the body of the loop. What is it you're going to do within the body of this loop? Well, option equals display menu. Call the function. So you're going to need a function call to go ahead and display the menu. All right, well, let's watch this behavior. So this is cool right now. Only 3 will be active. 1, 2, or 10, or 0, or -3 will have no effect on this loop. You will remain in this loop until you pick 3. So let's test it out. So compile and run. And notice here it says main menu. So if I enter 1, I'm going to remain in the loop. Why? Because option not equal 3 remains true. So what if I pick 2? Same thing. What if I pick 3 this time? Now I'm out. So that means the while loop expression, option not equal to 3, is false because it is 3, right? So we're testing Is it not equal to 3? Yeah, it is 3. So out. You're out. You no longer remain in the loop. Press any key to continue is really what's at the end of the program, which is your system pause here. Now, notice when, let me run this again. If I pick a 0, same thing. So it could be wrong information, right information. It doesn't matter. But notice that every time when I pick something, it's displaying, the console still has the old information. So this could be, very crowded after a while, right? So can we clear the screen every time? The answer is yes, there's a way. So let me just enter 3. And what we're going to do now is move system pause right here inside the loop. So let me just cut it. And as if your while loop is, at the end of it, is the possibility of having the end of the program. So let's see what happens here. So compile and run here. Right, so if you pick 1, again, press any key to continue. 2, press any key to continue. 3, press, okay, so let's see what happened when I picked 3. Did I press 3? No, I didn't press 3 hard enough. Okay, press any key to continue and you're out. Okay, so it's working. So, but in between, I would like to clear the screen. So every time, maybe we could clear the screen here. So maybe system CLS. Right here, we could do that now, or we could do it at the beginning, right? So let's see what happens when you do it now. So compile and run. So if I pick 1, press any key to continue, you're back here. So it clears the screen for us. Now, what if I do 2? Same thing, clears the screen. What if I pick 3? Well, it's going to clear the screen as soon as I hit and we're out anyway, okay? All right, so now that we have some sort of control, what are the other things we could do? Well, how about your operations, right? So would you like to maybe do a switch statement here, or an if statement if you want, based on option? Open curly brace, close curly brace, and then set up our cases, right? So we could do that. And notice we're going to do that right here, right after you picked what the value for option will be. So case 1, we could do cout, and this will be addition mode. So we know what are we in, /n, and then make sure you break. Okay, we will create a function for addition and subtraction as well, right? And but right now, I just want to show you what would happen and how to control your program one step at a time. I think I'm missing N here, missing a quote, double quotes here. There you go. And then put a break. So for each case, make sure you put a break. And then case 3, you could skip case 3 and do a break, which means it's not a default. Notice I don't have to do anything. And then default, this would be for anything other than 1, 2, 3. So notice for 3, no operation. A lot of people might call it no op. So cout. And this one will be an invalid. Heck, you can even display option. Something like this. Okay, so if you want to make it interesting. Notice default, you don't need a break. That is your last statement in this stack right here. So let's go ahead and try it out. So compile and run. So if we do a 1 addition, we're in addition mode. Notice it clears the screen nicely. So let's do a 2. We're in subtraction mode. Let's pick a 4. 4 is an invalid choice. As you can see, let's pick a 0. Same thing. Let's pick a -1 or a 100. So any value other than these 1, 2, 3 will give you an error message. Now let's pick 3. And notice press any key to continue and you're out. Now you could, if you want, display a message, see out, goodbye, or something like that. Notice I didn't do anything with case 3. So pay attention to case 3. I didn't do anything because I'm relying on the system pause to hold the screen before you get out anyway. Okay? All right, so now how about the addition and subtraction? Can we have functions to do these operations? Yeah. Can we have it return a value back? Sure. And there are several ways you can do this. So first, let's do addition. Let's focus on addition. So notice I'm going to write double. So I want my addition to return a float value, right? Double is a float value, right? That holds more space, or you could hold larger numbers in memory for it. And in here, I'm going to have double, num1, num2, and result. And we will return result. And then I'll ask the user to enter values, so cout, enter 2 numbers to add together. And these numbers could be real numbers with decimal points. Okay? And maybe something like this, cin, num1, num2. So you can add them all at once. Okay? And then once you do that, you could say result equals num1 plus num2, and then return result. This is one way to do it. Could I have simply returned num1 plus num2 without the need of a result? The answer is absolutely, right? So I could have rewritten all of this in one line of code without the need for a result variable. You will simply return the result of this operation. So instead of needing result like I have here, right, which is an intermediate variable, I could have the keyword return right here, no equal, simply return num1 plus num2. So in other words, I could have done this. Let me just take this out. Num1 plus num2. Do not put the equal sign if you do not want an intermediate variable like I have here. So this is one option. No matter how you slice it, right, you will return some sort of a value that is a float type. So this is a float addition. Okay, notice no equal here. If you want to put an equal here, that is not going to work. Okay, let's compile this for a second. Okay, and not a good idea to do this. Let me compile this, and you notice here you're going to get an error, right? Return is not a variable. Return is an actual statement that says return whatever is in here. If you want a variable, then make sure you have result right here, for example, and then cut this out right here and make result equal that, and then return result. So this is another way to do things properly. And let me go ahead and compile this. You could see that the compiler is not going to complain. So everything looks good. Now the key is, if you're returning that result, who are you returning it to? Well, first of all, we need to call that function addition. Where are we going to call it? We're going to call it right here. So we're going to do a function call here. But you're going to say, wait a minute. That function addition has a return type other than void, which means just like we did with display menu, you need a variable waiting for the returned value to be stored in it. And it has to be of matching type. So maybe something like this. Double result. Now you can say, well, wait a minute. You've just declared result up here, right here. And you're redeclaring it here. They're totally two different variables. This result only lives within that function addition. This result here is a totally different variable. It has the same name, granted, but it's a totally different world, okay? It only exists in main. So that's why it's called a local variable. So you could reuse the same names if you want to right here. And notice here, if I compile this, I shouldn't get any complaint. There you go. Now, we could say something like this. Result equals addition. So when is the operation going to happen? It's going to happen when you make this function call right here. Which means you're going to exit main and you're going to execute all of this. And then you're going to return results. So what are you going to do with it? Okay, well, might as well go ahead and display this. Okay, result equals, you could do it here since that's what you want to do with a function that returns a value. So now the value that it returns is meaningful for you within main. So you can do things with it, right? And this will be the local variable result, and then give me a new line. Now let's go ahead and investigate how this works. So let me compile and run. And let's do an addition. And notice again, it asked me to enter two numbers. Okay, so I'm going to enter 2 space and 7, right? So, or 7.1. Just make life interesting, right? So, what do we get? We get 9.1, right? So where did that result 9.1 printed? Where was it printed? Within main. Where was the addition done? Within the addition function. So what we're saying, let me just get out 3, is that you want your function to specialize in what it's supposed to be doing and nothing else. Don't try to cram stuff within a function. For example, you might be tempted to call it operation and then do subtraction and division and everything within that function. That's too many jobs in what's supposed to be one function. One job per one function. Okay? So it's a good rule. It makes design much easier, troubleshooting much easier. So if I want to do subtraction, then I will have a separate subtraction function right here. Okay? And if it follows the same pattern, that's fine. This time we're just going to simply return the difference between them. So double num1, num2. Except right now I'm going to ask for each number separately. So something like this, cout, enter a value. Okay. And cn num1. I'm just breaking it up. You could have done just like we did for the operation, for the addition. Cout, enter a value to subtract from, you could do this, num1. Don't forget your quotes here. And then something like this. There. I think that would work. And then cn num2. Okay. And then return num1 minus num2. So, okay. So I'm using a different flavor. So instead of having a result variable, just like I did for addition, I am simply going to return the result of an operation. Okay? So let's go ahead and try it. So how do we call subtraction? Same thing. Result, my local variable result, equals subtraction. Okay, so we need a function call here. Right? So go ahead and display the result. Cout result equals and then result, and L. All right, well, let's see how it behaves for the subtraction. So let's compile and run. Let me see here. Forgot my arrows here. Here you go for the second number. Okay, compile and run, and there you have it. So let's go ahead and do a subtraction. So let's say we enter 23.1. Enter a value to subtract from 23.1. Great, 7. And there you have it. Okay, so if I press any key to continue, notice it clears the screen. My main menu appears. I can go ahead and do an addition. So 1 and 4, right? Because this one here is slightly different. It asks you to enter the two numbers at once. Just separate them by a space. And here you go. Right? So if I pick 0, for example, I get invalid choice. And if I pick 3, I'm good to go. So now you can expand this calculator to do more, multiplication, division. In that case, what you need to do is add more items in the menu lines, right? And then have more functions. So that should be an exercise you should be doing right after you've watched this video or this lesson. And go ahead and do multiplication, division, and make sure you don't divide by 0, right? So have an if statement there to filter out if you're dividing by 0 and print an appropriate error message accordingly. So I hope you're going to have fun with this. We're going to be next reviewing, or actually getting into, functions that take argument. So it will have parameters or a parameter list, if you will, within these parentheses. So for example, if you want to do an addition or subtraction, you may want to provide num1 and num2 from main. And that's where you're going to need parameters, and the arguments will be the values you're going to pass to these parameters. Okay? So great. So I will see you again for the next lesson where we're going to have a parameter list for some of these functions.